All right, so this lesson is all about simplifying algebraic expressions and combining like terms. So on this first part, this does start in the workbook on page 151. If you want to go to the workbook page and write these things in, you can. Otherwise, I'm really just going to be checking when you get back that you've written things into your binder notes. So again, this page, if you want to write things in, you can, but otherwise just listen as I'm going through it. So it says, suppose one class collected P pounds of recyclables and a second class collected 6 more pounds of recyclables more than the first class. Number 1 says, write an expression to represent the pounds of recyclables collected by each class. Well, the first class, they told us, one class collected P pounds. The second class collected 6 more than the first one. So we have our first one was P plus 6 more pounds. Number 2 says write an addition expression to represent the total pounds. Total means we're going to be adding of the recyclables collected by both classes. So we have our first class plus our second class. Okay. And today we're going to be talking about what parts of that expression we can combine. First of all, that's an expression because there's no equal sign. Okay, but you cannot combine all of those parts. You actually can't do P plus 6, and we'll talk about in a minute why you can't add those two terms together. So it says, when addition or subtraction signs separate an algebraic expression into parts, each part is a term. So for example, if we have 2x plus 6, there are 2 terms here, and you know because it's separated by an addition or subtraction sign. So here's our first term. Here's our second term. Okay? It's separated by an addition or subtraction sign, and you have to take that sign with it that's in front of the term. So that was 2 terms. If we had something like this, that one has 3 terms. We have our first term, our first term, second term, third term. It's always separated by addition and subtraction signs. Okay? So it says, in this chapter we will work only with terms with an exponent of 1. I just showed you that 5x squared has an exponent of 2. So it is possible to have other exponents. They're really just going to focus on an exponent of 1, but we will have some examples where it has others. In this case, like terms are terms that have the same variables, such as 2n and 5n, or 6xy and 4xy. Okay? Notice what I have written in purple there that's highlighted. When I talk like terms, I want you to be able to tell me that like terms have the same variable with the same exponent. So if you have the same variable, like 2x and negative 3x squared, even though they have the same variable x, they don't have the same exponent. So those are not like terms. If I would have said 2x and negative 3x, those are like terms. They have the same variable, they have the same exponent. What doesn't matter is the number in front. Remember, this number in front of the variable here is called the coefficient. And the coefficient doesn't matter. So we can add 2x plus a negative 3x because, again, it has the same variable with the same exponent. So the first thing that we're really going to be concentrating on today is finding like terms. So when you look at this, it says underline the variables in each term, then cross out the terms in each group that is not like the other 2 terms. Okay? So when they say group, they're looking straight across like a row. Okay? So underline the variable. This one has an x, this one has a y, this one has an x. And cross out the term in each group that's not like the others. Well, this one has a y, so that is not a like term. 5x and 7x are like terms. In the next one, underline the variable C, C, D. So obviously the one that's not alike is 6D. On the next one, we have MN, NP, NP. So all of them have N in it, but they have to be the exact same variables. So since this one here has NP and this one has NP, those are like terms, this one is not. And the last one says RS, RS, ST. Again, even though they all have an S in them, this last one is not the same because they have to have an R and an S to be like terms there. Okay? Notice again, it doesn't matter what the coefficient is. I'm going to kind of tap so you can see where I'm looking here. This is a positive and this is a positive, but it doesn't matter when it's a positive and a negative. Okay, the number in front doesn't matter. It's the same variable with the same exponent. So it says, when addition or subtraction signs separate, and just so you know, sorry, backtracking, that was still in the workbook. This is our first page in our paper notes, and we are on 7.2, not on 7.1. We're skipping 7.1 for the moment. Okay? So it says, when addition or subtraction signs separate an algebraic expression into parts, each part is a term. So like we just said earlier, here's a term, here's a term, one more term, and this one has 4 terms. So it's separated by addition or subtraction signs. The numerical part of a term that contains the variable is called the coefficient of the term. So we said that means the number in front. So on this one, the coefficient is 3. On this one, the coefficient is a 1. Anytime you have a variable without a number in front, we assume the number is a 1. So there is a coefficient there. If there is no variable, so for example here, this +7 and this +2, there is no variable there, so those are called constants. Okay? Below it says, in this chapter we will work only with terms with an exponent of 1. I've already told you the book might do that, but we're going to go a little bit farther than that. It says, in this case, like terms are terms that contain the same variable and you have to think the same exponent. Okay? So same variable and same exponent. Last sentence says, a term without a variable is called a constant. So it has examples there. My like terms are like my 5y and my 2y because they have the same variable with the same exponent. Doesn't matter that the coefficients, the number in front, are a little bit different. And then there's one constant, that +3. This is in your workbook. Again, you can just watch. You don't have to write it in if you don't want to. Identify the parts of the algebraic expression below. So this first part is talking about the entire term there. It's 4x. So that is a term. Here it's just pointing to the number in front. The number in front is called a coefficient. And then this one is a number by itself without a variable. A number that doesn't have a variable with it, that is a constant. You are going to hear me saying those vocabulary words a lot. You absolutely need to know the difference between coefficient and constant. Okay? So if if you look at the first example, it says identify the like terms in the following expressions. When I do like terms, I like to use my highlighters to help me out. If you have highlighters, great. If you don't, you can always do underlines, circling, triangles, boxes, whatever you want to do for your terms. Okay? So the first one, we have 3x plus 4y plus 4x. I know these are my like terms. They have the same variable with the same exponent. So we can combine those. 3x plus 4x, it's kind of like we're skipping over that middle term there and just reading it straight across of what's highlighted. 3x plus 4x, well, that would be 7 x's. If I have 3 x's, I give someone 4 more x's, now all of a sudden that's 7 x's. Plus, we have to keep the other part the same. It cannot combine with anything, so it just stays plus 4y. And that's it. You cannot combine it anymore because 7x and 4y are not like terms. They don't have the same variable. So we're done at that point. That's as simplified as it gets. That is your answer. Okay. The next one, like terms. I can combine 5x and 7x. I also can combine my constants of 3 and 4. So 5x plus 7x, well 5 plus 7, you can just think about the coefficients here. 5 plus 7 gets you 12, so you have 12x. And then your 3 plus 4, that gives me a positive 7. So my answer on this one would be 12x plus 7. You cannot combine 12x and 7 together because they're not like terms. So don't show me 19x. That's not the correct answer here. Okay? You can only combine them if they have the same variable with the same exponent. The next one says identify the like terms in the following expression. So again, I'm going to identify them. If you don't have highlighters at home, what you can do is I like to underline like terms and then circle like terms. You can always put boxes, you can triangle, you can double underline. Okay, you have a lot of options of what you can do to show which ones are like terms. I like to use highlighters just so nothing gets covered up. Okay. So on this one, negative 4x plus my 2x, well, if I want to think this through, negative 4x plus 2x, that's really a negative 2x. Okay? Again, it's negative 4 plus 2 would be a negative 2, and I just keep my x on there. And then I have this part, and it's 2y plus 3y, which gives me a 5y. And I just put all of that together then. So I have my negative 2x and then a positive 5y. I cannot combine them. They have two different variables. Okay? The next one says identify the terms, like terms, coefficients, and constants in the expression. So 6x minus 2y plus x minus 5. My terms, I have 4 of them here. Okay, my first term is 6x. My second term is negative 2y. My third term is a positive x. And my last term is a negative 5. So there's 4 different terms there. Notice I separated them with commas there. My like terms. My like terms, I have a 6x and a positive x, and I have a negative 2y and a negative 5. So my like terms here, I would put 6x and x, and then also, actually, I have that wrong, I'm sorry there. That should be different because that one doesn't have a y with it. So I don't have any other like terms. That's it. Those are the only two that have the same variable with the same exponent. Okay? This one here is a constant because it is a number by itself. That is my only constant there. All of the other ones have variables. Every other term has a variable. And then the coefficients. If it is a constant, there is no coefficient to it because there is no variable. The other ones we have to look at, what is my number in front of the variable? On this one, it's 6. On this one, it's a -2. Take the sign with it. And on this one, it looks like there's nothing, but that really means it's a +1 there. Okay? So those are your coefficients, and the constant is that -5. On the next one, again, we're doing the same thing. This is just a practice now. When we get to the got it's, you can always pause the video if you want and try it on your own first, but you don't have to. You can watch straight through and write things down with me. That's up to you. So my terms, I have 3n. Then the next one is a +5m. Then the next one is a -6m. The last one is a +2. I go to find my like terms. 3n is a like term by itself. I don't see any other ones that have an n with it. I do see that this +5m and -6m are like terms, and then I have one constant left at the end. So the only like terms I have are my 5m and -6m. I'm sorry, that negative kind of got covered up there, but there is a negative there. It's a subtraction sign, but when we look at it just as the term, so we just look at that part isolated by itself. What I mean by that part is this part right here. Looking just at that as one term, that sign would be a negative instead of a minus there. Okay? Our coefficients are our numbers in front of the variable. This one's a 3. This one has a 5. This one's a -6. On the last one here, since there is no variable, that wouldn't be a coefficient, that is a constant. So our only constant there is 2. Okay? You should have this in your workbooks. I want you to try, or in your notes, I'm sorry, not your workbooks. I want you to try to find what the like terms are. If that means highlighting, boxing, underlining, triangles, whatever. Go ahead and try to find the like terms. Go and pause the video and try that. Okay, so hopefully now you've tried it. And I have 2x, -3x, +6x are all like terms. I have a -3y, a -5y, and a -4y. And then the rest are constants. I have a +7, a -8, and a +9. So those are my like terms there. Now, we're going to try to put them all together. Okay? So there's a couple ways you can do this. You can just think through it in your head. Okay, 2x minus 3x plus 6x. But for some of us, that might be more difficult to do. So if you need to kind of write this out, you're going to write it out. Okay, I have my 2x, then I have a -3x, then I have a +6x. Okay? And when you think about that, what you're really doing is adding down. So 2 plus -3 would give me a -1. -1 plus 6 would give me a +5. So that would be 5x. Or if you want to kind of rearrange them, you could think, okay, here my 2 plus my 6, that gives me 8. 8 minus 3, that gives me my 5. Okay? Then I have all my green ones here. My -3y minus 5y minus 4y. Well, since they're all negatives, that means I can add up what the absolute value would be, and keep my negative. So 3 plus 5 plus 4 would be 12. So I know a -3 plus -5 plus -4, that's going to be a -12. And again, you can use your calculator if you would like. But just make sure you're thinking about as you're adding each one of these together. Okay? We're totaling them up, so we're adding them up. And when we add them up, I get a negative 12y. And then my last one, I can't write in yellow and you guys be able to see it, so I'm going to switch colors. I'm going to use purple instead. I have a positive 7, a negative 8, and a positive 9. And when I add those up, 7 plus 9 gives me 16. 16 minus 8 gives me a positive 8. Now, I cannot combine any more than that. Those are my like terms, 5x minus 12y plus 8. Okay? None of them have the same variable with the same exponent, so that's it. That is my simplified answer. We have another one like that. So again, we're going to find our like terms. Negative 5x, negative 2x, negative 3x, and positive 9x. I have a negative 8y, positive 7y, positive 8y, negative 4y, and the last one is just my 12. Just one constant there. Okay? So I'm going to start with my x's. So I have my negative 5x, I have a negative 2x, I have a negative 3x, and I have a positive 9x. And again, I'm adding all of these things together. So negative 5 plus negative 2, that's negative 7, plus a negative 3, that's negative 10. Negative 10 plus 9, that gets me back down to negative 1x. Now, when I write negative 1x, I'm not going to write it like that. I'm just going to write it negative x. Okay? So that's a negative 1x there. Then I have my y's. So negative 8y plus 7y plus 8y and a negative 4y. Now, I notice right away my negative 8y and positive 8y cancel each other out. So really I'm just doing 7 plus negative 4, which would give me a positive 3y. Okay? Our constants always come last. If you were kind of wondering before how I knew which variable to start with, variables go with alphabetical order. X comes before Y in the alphabet, so that's why I did my X values before all of my Y values. Okay? And constants just always go last. So my very last one here is a plus 12, so I just keep it the same, plus 12. Okay? And you can use this method as you're going through the other ones. Some people tend to like this where I showed that you had your arrow with it together. But some people like to show it that I have, here's my 3x plus my 4x. That gives me my 7x. And then the last part, since it's not a like term with it, it just stays the same by itself. Okay? So if you don't like doing the arrows like that, you can always use that method for the smaller problems too. Okay? So it says, an algebraic expression is in simplest form if it has no like terms and no parentheses. The next part talks about distributive property, and that's in lesson 1, which we're going to do next. So we're going to ignore anything with distributive property for today. Okay? So simplify each expression. So I have my 4x plus 2x are like terms, and my positive 6 there is a constant. That's a like term. So I know my 4x plus 2x combines to give me 6x. My plus 6 is just by itself. It's the only constant. So I put it there. And now I have 6x plus 6. That is simplified because there are no like terms. Remember, like terms have the same variable with the same exponent. So it doesn't matter that these two numbers match. Okay? What matters is that this has a variable and this one is a constant. So those are not like terms. That's done. It's it. Okay? On the next one, my like terms are 5n and negative n, positive 2, negative 6. So I have my 5n and my negative n, and then my 2 and my negative 6. Well, that's really saying 5n plus a negative 1. 5 plus negative 1 is 4n. And that's saying 6 plus negative 2. Well, 6 plus negative 2, that's a negative 4. So I have 4n minus 4 on that one. Okay, again, those are not like terms. I cannot combine them. One has a variable, one does not. Letter C is with distributive property. Again, we'll talk about that in the next video. You don't need to worry about that now. Okay? So looking at the gottets, we have 4x and a negative 3x, and then a constant by itself here. On the next one, I have a 2m and a negative 7m, and then some constants as well. So first you always have to find your like terms, then you combine them. So my 4x and my negative 3x, well, 4 plus negative 3, that gives me a positive 1, so that's going to be a 1x, which is just x. Then my constant by itself stays the same. It doesn't combine with anything else. So it's x plus 6 is our answer there. Okay? If you prefer using what you're combining with the arrows, go ahead and do that. 2m plus a negative 7m, that's a negative 5m. And 3 plus negative 4, that's a negative 1. So again, I'm okay with either method, whichever makes most sense to you. That's what I want you to show me. If you need more examples, you can always go through and kind of try these to help you out. And I can always do these with you in our office hours if you would like to do a little bit more practice. But otherwise, there's some story problems. We're going to get on to that quick. It says, you have some money in a savings account. Your sister has $25 more than you in her account. Write an expression in simplest form that represents the total amount of money in both accounts. So when you look at that, it's breaking it up for you there. It says the words, the amount of your money plus the amount of your sister's money. So we know for the variable, we're going to use x as our money. So x is our money here. And since it said that your sister has 25 more than you, that means we're going to take our money plus 25 to represent your sister's amount of money. Since we want the total amount, that means we have to add. This is like the very first real-world link problem we did. So we have my money here plus my sister's money. Okay? And you have to figure out which parts are your like terms. So my like terms here are my x's. So I can take those x's and combine them. X plus x, that's really like a 1x plus 1x. Well, 1x plus 1x, that's 2x. Okay? The constant stays by itself here. So then we have our plus 25. So it would be 2x plus 25 would be our expression. The gottets here. I don't know how to say that first name, so M is what we're going to say. M and Lola both collect stamps. Lola has 16 more stamps in her collection than M. Write an expression in simplest form that represents the total number of stamps in both collections. So I'm going to have M be the first one they talk about. That's how many stamps that they have. And then we know that Lola has 16 more than that. So we have to take M's amount plus 16 to get Lola's amount. So if we want the total amount, I have to take the first person plus the second person. To simplify, I know that M and M are like terms. So M plus M is really 2M and there are no other constants, so it would be just plus 16. Okay? For B says, adding another person into this problem, what about if Derek has as many stamps as M? Write an expression to represent the total of all three collections. Well, we have the total of the first two, and then all of a sudden Derek also has the same amount as M, so plus M there. Now we have more like terms we can combine. We have 2M plus M, so 2M plus 1M, that would give me 3M plus 16. Again, you can only combine them if they have the same variable with the same exponent. Okay? That is all of the notes. We do have a short homework assignment that I want to kind of explain to you. So when you look at this, okay, so this is going to be what your worksheet looks like. Ignore the part that says about academic assist that was used a couple years ago when we had that. It says color all of the like term boxes with the same color. There should be 8 different colors needed for this assignment. So you're going to go through and find your like terms, and at the bottom I want you to put a key. So notice my first one, and you can write this out, but I don't have my laptop, so it was hard to write it out and make it still look nice. So AB squared. So when you go to fill those in, whatever color you write it in, that's what you're going to color all of the boxes with AB squared. You're finding the like terms. I don't care if when you do it, if you just shade around the outside like this, or if you change the transparency so you can shade over top of it and still see it, but please do not have it all the way across and cover it up. Okay, we don't want to cover it up and not be able to see it at all. Okay, so it doesn't matter to me how you do it, but that means everything with AB squared is going to be green. So notice this one right here, I can't do that one in green because it doesn't have the squared, but this one could be in green. So I would kind of box that around. Sorry, I'm trying to do this with the mouse, so it's not great. Okay, and I'd go through the whole thing, and anything where I see an AB squared, I would put it as green. Okay, I also have constants. All of my constants are purple. So notice I have 1/3, I have 42. Here I have a negative 25. And again, you could change it so you can color the whole thing in, or you can just color around the number. Doesn't matter to me. And you're going to go through, and it should end up with 8 different colors that you would need. So I should see 8 different things down here with different colors. And don't forget, you can always go in here to get more colors if you need different colors to show. Okay? That should not take you very long to go through and find just the like terms. You don't have to add them up or anything like that. I just want to make sure you can identify what different like terms look like, and you're not trying to combine things that don't have the same variable with the same exponent. Okay? Let me know if